Today we will discuss about internal energy. What is internal energy? Normally, internal energy is the sum of all types of possible energies that can be stored in a body. So we can say it is the sum of all possible energies. So when we have different types of energies, the sum of that will be considered as internal energy. So we can say that it is denoted as U. Consider from the law of conservation of energy that we are saying the total energy is always constant. It means total energy equals to potential energy and kinetic energy, because here we are thinking about two types of possible. One may be at the rest and one may be at the motion. Similarly, a body can have different types of energies such as kinetic energy in the form of vibration, heat, rotation, sound energy, sound waves, colliding energy. These are the varieties of energies that can be stored in a body. Right now I'm talking with you. That means my body is releasing heat energy, and I have producing sound energy. Some vibrations are going on around my surrounding, and so many energy stored in my body. So that total energy is called internal energy. Then what will be the consideration? Now we can say, I told you that it is the sum of all possible energies. Consider I am discussing that it is the final energy that we have to calculate U2, that is equals to initially something has energy that is considered as U1, and I told you my body is releasing energy. It may possible that I may release heat energy, I may absorb heat energy. So that is Q may be positive or negative. When I am absorbing heat energy, it means my system is gaining heat energy. In that case, Q is positive. In case I am releasing, means my system is losing heat energy. In that case, I will consider Q is negative. So I will write Q simply here. It may be positive or negative. Due to the gain of energy or loss of energy, work done may be on the system or by the system. We know that work done on the system means system is gaining energy and it is considered as positive, while W is negative, work done is negative, it means system is losing energy, that is work done by the system. Here also we can write W, which can be positive or maybe negative. Now separating this term, what I will get, that U2 minus U1 equals to Q plus W. So I will get that del U is equals to Q plus W. This is our equation, and we know that W, work done, it is a path function which defines as the pressure volume work, means mechanical work. So we can write W PV in place of W. So our equation will be like this: del U equals to Q plus P del V. Now we can see the change in internal energy that is related to change in volume. What if I will consider volume is constant? Let's say volume is constant. If volume is constant, we can say del V is equal to 0. So in that case, our equation will be like this. We have del U equals to Q V constant, P into 0 is 0. So we can say that del U equals to Q V. Q is the amount of heat absorbed at constant volume. So our new statement for the internal energy is that it is the amount of heat absorbed by the system at constant volume. So this is our next definition, another definition, that internal energy can be explained in terms of heat with respect to volume. Then we will discuss what are the characteristics of internal energy. So if we are discussing about characteristics of internal energy, it means we know that internal energy is an extensive property because it depends upon the quantity present in the system. As the size of the system increases, as the amount of the system increases, internal energy increases or decreases. As something is depending upon the amount of the system, then it is an extensive property. So internal energy U is an extensive property. Next, and we know that it is a state function. Internal energy is a it is a means internal energy is a state function. Now, why it is a state function? Because in the formula of internal energy, we found that it depends upon state variables such as pressure, volume, and temperature. So the factors which depends upon the state variables are called state functions, and state functions does not obey the path followed by the system. So it does not follow. So it is independent of path followed by the system. So whether we are doing A to B, B to C, C to D, or A to D directly, it doesn't matter. It will just find what is the internal energy. Now, if we are not considering the path followed by the system, it means we cannot determine its absolute value. So we cannot determine its absolute value. If we cannot determine its absolute value, so we have to determine its differential value. We can determine its differential value. That is du equals to u2 minus u1 equals to del u. Now we will discuss about some laws of thermodynamics. Now first we will discuss about zeroth law. we are discussing about zeroth law, just consider I have taken 3 bowls of water. I have taken 3 bowls of water. That is, one is hot. I have taken hot water here. I have taken here normal water. I have taken here cold water. Now I will place my two hands in two separate systems. Just consider I am placing one hand in hot water, another hand in cold water for few minutes. Then after I will feel one of my hand is feeling very hot, another one is feeling cold. Now simultaneously I'll put both of them in normal water. What I will feel? I will feel the hand which is in the hot water, that is feeling cold, because in the hot water my hand gained energy, so extra energy is stored in my hand. When it is stored in normal water, the temperature is different due to the difference in temperature, and we know that energy flows from the higher level to lower level, due to which my hand will start losing energy to the normal water. That's why this hand will feel cold, while about this hand which is placed in cold water, here my body has lost so many energy and it is feeling cold. And when it is coming to normal water, I will feel due to the difference in energy, normal water has higher energy than the cold water, due to which my hand will start gaining energy from the water, due to which I will feel hot. It means energy always try to maintain the equilibrium, that we are saying thermal equilibrium. So that is all about the zeroth law. That let's say two systems A and B are separately in thermal equilibrium with third system C, then A and B are in thermal equilibrium with each other. So this is the statement of first, means zeroth law of thermodynamics. Next one is first law. Now we will discuss about first law of thermodynamics. It is also known as law of conservation of energy. What law of conservation of energy says? That energy can neither be created nor be destroyed in a chemical reaction. It can be converted from, or it can be changed from one form to another. Total energy of the system is always constant. We can see we cannot, in our surrounding, we have so many types of energies. We have never created any energy and also have never destroyed any energy. There is a kinetic energy stored in water in the form of rivers. There we produce electrical energy through the use of turbine, and that electrical energy is in our house, which converts into light energy, heat energy, mechanical energy, and etc. So we are always converting energy from one form to another. That is about first law of thermodynamics. What it is saying? That energy can neither be created nor be destroyed. It can only be changed from one form to another. Total energy of the system is always constant. That is, we can say total energy equals to potential energy plus kinetic energy. Now we will discuss about second law of thermodynamics, which discuss about the entropy. Entropy means randomness, disorderness of the system. What second law says? Let's see. That the entropy of the universe is continuously increasing. The entropy of the universe is continuously increasing and tends to be maximum and tends to be maximum for every spontaneous change. So whatever the change we are doing, due to that the entropy is increasing. That is the statement of second law. What about the third law? What about the third law? At absolute zero, at absolute zero, the entropy of a perfectly crystalline body is taken 0. These are the laws of thermodynamics we have to remember. Now we will discuss about enthalpy. It is denoted as capital H. Enthalpy, one type of heat that we are discussing about. So we can define the enthalpy. It is the sum of internal energy and product of pressure and volume. So in simple, we can write that H equals to U plus PV. Now we can find that at initially H1 is equals to U1 plus PV1, and in final condition H2 equals to U2 plus PV2. What will be our change in enthalpy? If we will find the value of change in enthalpy, that is del H equals to H2 minus H1. The value of H2 is U2 plus PV2 minus U1 plus PV1. So solving that, separating with respect to common factors, U2 minus U1 plus taking P common from this, we will get V2 minus V1. So our final answer will be del H equals to del U plus P del V. This is our formula we got. In internal energy, I told you and also proved you that the internal energy is the amount of heat absorbed by the system due to the at constant volume. Similarly, if we make pressure constant, the amount of heat absorbed by the system is considered to be enthalpy. So we can define that it is the amount of heat absorbed at constant pressure. So we can say that QP equals to del H, and we know that del H equals to del U plus P del V. So we can write that QP plus QV plus P del V. Another equation. These can be applicable if all the factors are in gaseous state. Now from ideal gas equation we know that P del V is equals to del nRT. So we can write that del H equals to del U plus del nRT, or QP plus QV plus del nRT. This can be written also. These are very few required. Now, after that, we got the relationship between del H and del U also. Now, what are the characteristics of enthalpy? Always remember that all the external properties have similar characteristics, and we know that gas free energy, enthalpy, internal energy, entropy, these are called what? Extensive properties. Now we can see enthalpy is an extensive property and it depends upon the pressure and volume. So it is a state function. As it is a state function, it does not depend upon the path followed by the system. So we can say it is independent of path followed by the system. If some process is independent of path followed by the system, it means we cannot determine each value of the step, value of each step. In that case, we will not able to determine the absolute value. In case we are unable to determine the absolute value, so we will calculate its differential value. So these are some very few characteristics of enthalpy. Okay.